Hey guys, what's up? Let's do some examples on circular motion. Our next example is fourth. That is, a coin is kept at a distance of 10 centimeter from center of turntable of radius 1 meter. Just begins to slip. When the turntable rotates at speed of 90 rpm, calculate coefficient of static friction between the coin and the turntable. Okay, we have to calculate our mu, that is coefficient of static friction. So we'll solve this problem. Okay, we will solve this problem. Just a minute. This is a turntable. And a coin is here. And this is the center of our turntable. So from this center, this coin is kept at, from this center, our coin is kept at how much distance? Distance of 10 centimeter, isn't it? That is given in our example, that our coin is kept at a 10 centimeter distance from the center of this turntable. So you have to literally think about it, that what will happen if this turntable is start rotating, then this coin will slip, na? You have to imagine those things. And this coin will slip outside, isn't it? You have to think about it. Because this turntable is rotating and this is the center and this is coin, and the radius of this turntable is given to us, that is what? 1 meter. So this 1 meter is the radius of turntable and this coin is at 10 centimeter distance from the center of turntable. So this coin will slip, and this coin, when this coin will slip, that will slip in this direction, and this direction is what? This direction is away from this center of turntable. Okay, so force will be centrifugal force, na? I have taught you in my previous video, the centrifugal force is directed away from the center. So centrifugal force will be active in this case. So we can write our equation. So in this case, force of static friction will be equal to force of centrifugal. Okay. So mu of static friction, that is coefficient of static friction, into mu into normal. Isn't it? This is what we have taught, na? Mu into n is equals to force of centrifugal, isn't it? So mu of static friction we have to calculate, and normal is what? Normal is mg on that coin. This is our coin. So this coin will have normal in this direction. This is the normal, and mg will be in downward direction. Isn't it? And normal and mg are equal. So that's why I have written here normal is equal to mg. That is mu s into mg is equals to force of centrifugal R mr omega square. So m and m will get cancelled, and whatever is remaining, so we'll go to the next page because I don't have any more space, so I will go beyond this. Okay, mu is into m was getting cancelled na. Look into this, m was cancelled. Whatever is remaining I have written here, mu s into g, that is equals to r omega squared. Okay. And in this example, we have given the frequency, that is what 1.5 Hertz. Omega is 2 pi n squared divided by 9.8. That is what the value of G, that is meter per second square. We have to do all examples in the meter per second, that is MKS system. So by squaring this we get 4 pi squared, and square of 1.5 is nothing but 225 into 10 raised to minus 2, that is nothing but 2.25, isn't it? Into radius. What is our radius? That is 0.1 meter. It is given in our example, divided by 9.8. So I will take new page because my space is completely consumed. Mu s is equals to, final our answer is mu s is equals to 0.9066. So you can calculate on your calculator. I just provided the final answer because you can cross check by doing this. So this was our fourth example. Let us look fifth example. Okay. Fifth example is a rotor has a diameter of 4 meter. The rotor is rotated about central vertical axis and occupant remains pinned against wall when linear velocity of drum is 8 meter per second, and compute coefficient of static friction between wall of rotor and clothing of occupant. Also calculate angular velocity of drum. How many revolutions will it make in a minute? So revolutions per minute is asked to us in the last example. So we'll solve that. Okay. I hope guys I am making sense to you. I hope you are listening to me. You have to imagine that here is a rotor that rotor is rotating and one occupant is here. One occupant is here. He is pinned. Isn't it? That is what given in our example. The occupant is pinned and we have to think about it. We have to really draw his FBD because the example is really simple, but you have to think about it. So normal will be in this direction. This is what the normal force direction, and mg will be in regular manner, that is in downward direction, that is mg, and normal in this case will be in the negative x directions. And our force of friction will be in the upper side because due to the weight of this object, weight of this man, that is what mg. So he will move in the downward direction. So the work of the friction force is to oppose the motion. So that is what the friction force is in the upward direction. So normal force in this case is not in the upward directions. In the upward directions is only the friction force in this case. So you have to draw the FBD. So the diameter of drum is given 4 meter. We will write that. This radius we can calculate by doing d by 2, that is 2 meter. Isn't it? And velocity of drum, linear velocity of drum is given to us. That is what 8 meter per second. 8 meter per second. And we have to calculate mu, that is coefficient of static friction between drum and occupant's clothing, and the number of revolutions per minute, that is what the frequency is asked to us. Okay, I will take another page. Occupant should remain let me write first. Occupant should remain pinned. So one condition is given in our example. Occupant should remain pinned in the wall. So our coefficient of static friction, that is mu into n, that is friction force mu into n, is equals to mg, isn't it? Because see, in the previous page I have drawn the FBD. So to remain this occupant pinned, we have to balance this force of friction and mg, isn't it? This is force of friction and that will be equal to mg. Then and then only it will become pinned throughout the rotating. So mu into n, that is mu, static friction, coefficient of static friction into normal should be equal to mg, and normal in this case is horizontal. We know this, and normal in this case will provide necessary centripetal force. So normal should be equal to mr omega square or mv square by r. You have to think about it. So what we'll do is, mu we have to calculate, and we will put our value of normal, that is mv squared by r, isn't it? I hope guys I am making sense to you. Mv squared by r is equals to mg. Mm will get cancelled, and whatever is remaining is our final answer, that is mu is equal to g r by v squared. Okay, I will take another page. Mu is equals to rg by v squared. What is r? R is 2 meter. We have calculated by d by 2. We have calculated our r. So r into g is 9.8. 9.8 divided by v square. What is v? V is the drum's velocity, isn't it? So v squared. After doing this calculation, we can get our mu. The mu is nothing but 0.3063. 0.3063 is the value of mu s, that is coefficient of static friction. We have to calculate omega. So V is equal to R into omega. We know the formula, R into omega, isn't it? So V is 8 and R is 2. As we know, we have put it in the formula, into omega, and omega becomes is equals to 4. And unit of our omega is radian per second. Isn't it? Radian per second. By this, we have to calculate n. That is, omega is equals to 2 pi n. 2 pi, because we have to calculate n, na? That is what asked in the question. Omega is equals to 2 pi n. Omega is 4 in our case. 4 divided by 2 pi. You can calculate this by your calculator. I will give you final answer. This is what? This is hertz. Unit of our frequency is hertz. So we have to calculate. Hertz is nothing but what? Revolution per second. isn't it? So we have to calculate revolution per minute. That is what is asked in the question. Revolutions per minute we have to calculate. So we'll do that. 4 by 2 pi. This is what revolution per second. We have to calculate revolutions per minute. So we multiply by 60. After multiplying with 60, we will get the final answer. It is what 38. Let me just remove this because I done it by wrong. By mistake I have done that. Okay. Our final answer is 38.19. A revolution. That is what? Revolution per minute. So this was our 5 basic examples. And after this I will take all complex examples. Okay. I hope you like my teaching. If you like this video, please like, share and subscribe. Thank you.